it would be a good topic to talk about the power sources, primarily batteries. And so I put this together. I am no expert on batteries. The more I dug into this, the more I realized that there's so much going on in the field. So, so if I say something that's incorrect or you want to get clarification, please stop me and so on, and we will we'll try our best to learn some more about it. And I see that we're recording this. That's fine. Um, so tonight we'll talk about really fundamental stuff. What's a battery? Some history of batteries, and one of the things I discovered while looking at the history was how long ago a lot of the technology was developed, and how long it takes from developing something that works to actually commercializing it. So those are very different things, and getting the costs down as well. So we'll talk about the overall energy density. How much power, how much energy can you put in a given piece of stuff? A kilogram of material, and what are the limits of that, and how much does it cost, and so on, and how has that changed over time? And then we'll look at some of the latest technology, the lithium iron phosphate, which some refer to as LFP, and the LiFo or lithium polymer batteries. We'll look at a couple scenarios with a QRP rig or versus a 100-watt rig, portable power stations, briefly solar power and batteries, and then what to look for in a battery or battery pack for your ham radio, a few safety items, and some optimization tips. And then even a little bit on the future of batteries, which is kind of interesting topic all in its own. All right, I'm not going to belabor this. Most people know what a battery is, and I found three different definitions, but in summary, each definition talked about storing chemical energy and converting that to electrical energy when needed. Going back, I once heard a quote that if you don't know who said something, just tell them that it was Benjamin Franklin who said it. In this case, it was actually Benjamin Franklin who coined the term battery back in 1749. As he, of course, he was playing with his kites and that sort of thing, but he actually was very interested in electricity, and so he had these Leyden jars and whatever, and it reminded him of a battery of weapons, like you would see in a fort. So that's where the word battery came from. And around 1800, Alessandro Volta developed his voltaic pile. In fact, in French, to this day, they use the word pile to mean battery. So if you look at a carton or whatever at the store and you see the word battery in English, it should have the word pile or pile in French also on that. So this is where it came from. He stacked piles of copper and zinc alternating with a piece of paper that was soaked in brine. And the more he put together, the greater the voltage was. So you can see an actual one of his original batteries in a museum on the lower right. And then 1836, so this is all 36 years later, this guy, John Daniell, made the first modern storage cell using copper sulfate and zinc sulfate. And so you've got zinc metal, and you've got this copper sulfate solution, your electrolyte. And there was part of his patent article showing how it worked. And when you put enough of these together, they were the first sources to power telegraph lines and then telephones in various forms. Nothing stayed the same for very long, but the physics or chemistry was pretty similar for quite a while. Then this guy, William Grove, developed his fuel cell way out of his time, 1839. We're still talking about hydrogen fuel cells today, powering cars. And he got the hydrogen and oxygen from electrolysis of water and then was putting them back together through electrodes and was able to come up with a gas type battery. So some of these ideas have been around a long time. And then, of course, in your car, a lead acid battery. This guy, Gaston Planck, in 1859 came up with the original. So, and you know, electric cars came out before the gas powered ones. So this is one of the original types of cells that went on to be, well, we still use today, actually, the same principles. Charles Leclanché had the carbon zinc wet cell battery in 1866. And I think we still use those back into the 1960s, 70s, maybe even a little beyond, the dry cell battery based on his mixtures and whatever, 1.5 volts. And then, but the first commercially successful dry cell battery was by this guy, Carl Gassner, in 1888. And he had zinc chloride, ammonium chloride, and carbon solution in there. So these, it's taken already 88 years from the time that Volta came up with his piles of zinc and carbon, or zinc and copper, to come up to this point. And then this guy, believe it or not, Waldemar Jungner, came up with the original NiCad battery. I thought these came out like in the 50s and 60s, but that took that long to be very commercial. And so you had cadmium on the cathode and nickel on the anode, and then you had potassium hydroxide filling in between, and they were made airtight so they didn't leak. And each cell produced about 1.2 volts, which is a fairly common thing that we're seeing in a lot of these cells, 1 to 1.5 volts per cell. And you look back in 1899, to recharge this took 10 to 12 hours to get 1.2 volt back. So this was what they call the C/10 rate. So if you're delivering 1.2 volt, I think it's number of amp hours, you divide it by 10 for amps. So it's a 10 amp hour battery. You charge it at 1 amp, and that would be, it would take 10 hours to recharge. Thomas Edison got into the game as well around 1901, and he came up with a storage battery called the nickel iron cell. And there's an actual picture of one from a museum. This one was 6 volts, and it delivered 7.5 amps for 7 hours. And then it required about 120 to 150% of that 6 volts to charge it up again at 1/10 the rate. So you would spend another day or so recharging it, and then it would discharge in 7 hours. Things have come a long way. Here's a Canadian in 1949. I don't know if he was a ham operator or not. He kind of looks like one. Yeah, you can judge. There's the ever ready bunny behind him. And he developed the alkaline cell. And they lasted 5 to 10 times longer than what had been used for many, many years of zinc carbon. But they were very expensive, 2 to 3 times as much as a zinc carbon battery. But when you looked at the cost per watt hour, it was much less. So they overtook the carbon batteries pretty quickly. But again, I was surprised because I didn't see alkaline batteries till I was probably around 20 years old or something like that. And then in 1954, at Bell Labs, where we know what else they invented, they um, came up with the first solar cells. And these are about 6% efficient. So it was a start. But I love this picture on the top left where you see the rays of sunshine coming out of the sky. Everybody's amazed hitting this thing. And Bell system, solar battery converts sun's rays into electricity. Big news, 1954. 1960s, the nickel metal hydride cells came about. Um, and so, again, I thought these were like invented around the 1990s or something like that. But they originated back then. And they had 2 to 3 times the capacity of the NiCad batteries of the same size because they had higher energy density. Although they were only about half the energy density of lithium-ion batteries today. By 2008, more than 2 million hybrid cars worldwide were manufactured with this type of battery. But by 2010, not much longer than a couple of years, they were in decline because of the new technology. And so if you plot kind of from 1991 to 2019, the energy density and the cost, whatever, back in 1992, it was $6,000 per kilowatt hour if you added up all the batteries. And then it started to rapidly decline. So by 2016, you had a huge change in efficiency and storage capability. The price per kilowatt hour was now like $300 as opposed to $5,000 back then. Just huge. This is a logarithmic axis here of how much capacity. And this is basically, they're trying to plot all the world's batteries, how much capacity had been added. And by 2016, 100,000 megawatt hours of batteries had been produced. Another kind of sad story, the lithium iron phosphate battery was originally developed in Quebec. It's a Canadian invention, University of Montreal, and around 2003. So that's quite a while ago. German company recognized the significance and built a plant in or near Montreal, but it died. It wasn't successful. MIT had a group to manufacture their own version. It wasn't enough to make this battery work. It had to develop an efficient, cost-effective means of mass production, and that was the big problem. And they went bankrupt after 3 years trying to do this. So what they did was the Chinese were interested in this, and so they agreed to allow the Chinese to use their patents as long as they kept the batteries and the technology in China, which they agreed to. But then eventually the patents wore off, and now the Chinese basically, in the meantime, it took them about 6 years, but they figured out how to get the costs way down. They came up with their own manufacturing techniques, and so now they're sort of they have a monopoly on these LFP batteries. And this is projected growth for demand so this is 2020 to 2030. It's just still taking off. And we're all familiar with these 18650 batteries. Here they are. This is a multiple modules wired in series and parallel to create a 52 volt battery with 2800 amp hours of capacity, or 146 kilowatt hours. And that's what's powering a lot of vehicles or other things that require a lot of current. So this is just a summary of where things are. There's a bunch of different battery types that we've seen, from 1800, the voltaic pile, all the way to advanced lithium-ion batteries now, and emerging some lithium metal batteries they call solid state. And there's the projected or actual to projected energy density in watt hours per kilogram. How much energy per amount of stuff. And it's still going up. Or if we look at energy density versus time, there was a period from 1800 with Volta all the way around to 1990 where it was a fairly low curve or slope on this, but then all of a sudden with lithium ion technology taking over and a bunch of different groups working on this, it's just taken off. And the energy cost is from the early lead acid batteries through NiCads. Lithium ion was expensive early, and then they solved some of these problems. And it's been getting cheaper and cheaper ever since. Okay, so now let's switch gears a little bit and talk about these latest batteries that most of us are familiar with. For a while there, we just saw these lithium polymer batteries before the lithium iron phosphate came out. So I just did a comparison. These LiPo batteries are still in use. You can still buy them, and they have their place. So I'm comparing these LFP versus the LiPo batteries, and the LFP ones are lower energy density, but the LiPo ones are less safe. They're more prone to thermal runaway. Even though they're both lithium, they're a different construction, different chemistry inside. The LFP batteries are more tolerant to overcharging, over discharging, and physical damage to a certain degree. They have a flatter discharge curve and are more predictable, which helps reduce stress during use. They cost about 20 to 40% more than the LiPo batteries, but actually they're cheaper over time because you can recharge them a whole lot more. They can be recharged typically 2,000 to 5,000 is what I was seeing. If you do, if you're very careful, maybe up to 7,000 cycles. The LiPo 300 to 1,000. So if you're going to be using them and recycling or recharging them a lot, it makes sense to get the LFP batteries. They are heavier, but another advantage is they sit at about 13 volts for most of their use until the charge goes away. So they're very stable. They take longer to charge than the LiPo, as they're optimized for higher current and speed, while the LiPo is optimized for higher current and speed. But the LFP batteries are optimized more for stability and longevity. And here's a main point here. Both types, it's not an actual requirement, but it's a strong recommendation to use what they call a BMS or battery management system. And what that does, it reduces overcharging or over discharging, overheating of the cells. It basically senses what the current capabilities are within the cells. It can balance the cells, and it can keep things basically optimal. You can buy batteries off the shelf that don't have this, but you should put them in something that, or have some kind of BMS that manages them. Otherwise, you will you run the risk of damaging them, overheating them, or just reducing the lifespan. So here's a QRP scenario. This is scenario A. And I picked 3 rigs, the Elecraft KX2, the successor to the FT817, and the IC705, which are all 3 are very, very popular rigs. And so comparing them, weight, the types of batteries that are internal, if they have, what they're mainly used for, and what type of battery is recommended. And this information was, again, a lot of this came from ChatGPT as far as what the recommendations were. So if if some of these seem inaccurate, it's possible. But basically saying that if you had a KX2, you could expect 3 to 6 hours of runtime with a battery that weighs less than a kilogram at this capacity. Some like the IC705, you need a bigger battery than the 10 watt. But again, a lot of it depends on what mode you're running. If it's CW, or if it's phone or FT8 with the heavy duty cycle that it has. So these are just kind of guidelines. But you can see, for example, the same 3 rigs, there's sort of the recommended batteries. I just put a picture at the bottom. So this one, and they're suggesting this BioEnno, and there's models. We'll post this presentation if you want to look at this later, and look up those battery numbers and so on. And the capacities, this one in the middle, 3 to 6 hours if you're running sideband or CW. This one here, 4 to 8 hours, sideband or mixed use, but you're getting a much bigger battery for this one here. So this is the sort of thing, if you're really like with a backpack and you want to go very lightweight, the KX2 is a great little rig. I've used one and they work great. And you don't need a whole lot of battery to support that for a few hours if you're going to a summit somewhere. The other one is the 100 watts. Here took 3 popular radios again, and this one's running about 10 watts, 6 watts for a portable operation, and 5 to 10. So kind of looking at something similar in terms of power consumption, the weight, recommended batteries, and hours of use that you can get out of it. And again, sorry, this is all I had on here. But if you're going out on a picnic or something like that, you could buy these types of battery packs and get this kind of performance. There are portable power stations that have batteries built in that you recharge, and so they will come with either a LFP battery or a LiPo battery with a battery management system. They'll have an inverter quite often, and so you can plug in lower power type equipment. You can charge them up with from your at home from the AC, or you can put your car or solar power to recharge them. So this is one example that's about $800. And then there's solar. So I looked this up, and some of these flexible solar panels, 100 watt, they're classified as 100-watt solar panels. These are Canadian prices all in here, by the way. So topping up a battery station or a power station like this, this one is LFP battery with USB-C jacks on there, 1 hour fast charge. And so it's designed to be supported by a solar panel as well. So if you're going camping somewhere and you have room for this in the car, whatever, it's not a bad deal. And there, just by itself, the solar panel here, what they typically do is if it's real bright sun, 18 to 20 volts they're putting out. And so that's why you need that BMS, because you put that into the charge controller and you'll get out your 12 volts for your radio. Again, it's producing 18 volts and you need 12, so it has a DC to DC converter. So one of the things you do need is what's called a charge controller. And this, they talk about the maximum power point tracking, or MPPT controller. It's because solar panels don't produce constant power over time. So they have a sweet spot where a particular voltage and current can maximize the delivered power. And so this controller tries to work at that sweet spot. And so again, looking at somewhere around 13 volts for supplying 13 volts consistently to a radio. So if you do the math, 18 volts at 5.5 amps, that works out to about 100 watts. But when you drop the voltage down to 13.8, you can then produce 7+ amps of power to a radio. And they'll be very, very efficient doing that. So there's various charge controllers. Here's a couple that I found. They're about somewhere between $120, $160, something like that. And they can help balance off what the solar panel is doing if you want to do that. There are all kinds of these. These are just a couple examples. This is a good example of ChatGPT confusing itself. I asked it to draw a complete QRP POTA system with solar panel, 100-watt solar panel, the MPPT charge controller, a 12-volt 20-amp battery, and so on, and the KX2. And it did a pretty good job, but I looked at these colors on the cables, and they don't make sense. So don't take this literally, but this is a kind of system that you could put together. It's got the main components right. And I gave up after 7 attempts to draw this properly, and it kept saying, oh, you're right, I messed up. But you get the idea. If you want to go portable and you have a cabin or whatever without electricity, which is not very common these days, or go someplace out in the backcountry, then you could do this. All right, so let's review what to do, what to look for a battery. You want to have the proper voltage, typically around 12 to 13 volts. A compatible charger. You want sufficient capacity. Depends what you're running. QRP, an HT versus portable transceivers running 10 to 20 watts or 100 watts. And then the weight of it. Some enclosures are better than others. You have Anderson power poles and so on. Is it for a go kit? So those are considerations you want to look at. For safety, common warning signs. I have some batteries here. I remember, I'll show it later, but I had this one little LFP battery in a box, and I noticed that it was starting to bulge. And someone told me, you better get rid of it because it could catch fire or do something because that bulge is not normal. So I got rid of it. I don't recall how though. Okay. Anyway, you have to treat them nice because there's a lot of energy stored in there. Lithium batteries, there's a whole variety of these different types. Watch for swelling, like I just mentioned. A friend of mine had a battery pack for his laptop, and he disconnected it, and it was getting hotter and hotter and hotter, like extremely hot. We put it outside. It didn't explode or anything, but we were afraid it would. Finally, it just cooled off eventually, but it was a runaway battery, lithium-ion battery pack. So what happens? You should just stop using them immediately, put them away from people as far as you can, and allow them to cool and dispose at a proper facility. For nickel metal hydride, they can leak. Look for corrosion, avoid skin contact, and so on. This is true for all of them. Use the correct charger for your battery type. And don't leave charging batteries unattended, which most of us do anyway. And a thing that I was talking to Doug, CID, and he was mentioning about mislabeled batteries. you go online and you can get some pretty good deals, but you wonder what's in some of these things. And quite often what some unscrupulous companies or people are doing is they're taking the box or the plastic cabinet from one set of batteries and taking the good ones out and putting other stuff in there. So buy from a reputable company. And if it's unusual weight, if it's too light, there's something wrong with it. If it doesn't have a good battery management system, you can run some risks of other nasty things happening. And this is a handy chart. I found this online to optimize these LFP batteries. Avoid charging to 100% or discharging below 10%. Normally, they recommend between 20 to 80%. So don't overcharge, don't overuse it. Store them in a cool, dry location. For long-term storage, they shouldn't drop below 40%, but they can a little bit. Use a BMS and keep the terminals clean and connections tight. Avoid charging below freezing temperatures. Some batteries have protection for it, but not all. Don't store them fully charged for long periods. I was talking with Don, BED. He was showing me his thing he bought a year ago, and he had charged it up fully and then let it sit for a year. And that's not advisable. They say even if you charge it to 100%, you should run a small load after charging just to bring it down a little bit. That'll be a safer thing to do. Some batteries recommend being charged, the manufacturers recommend every 2 months to top it up a little bit. And know that the fully charged cells reach about 3.65 volts. So that's how you can actually see how fully charged they are. For example, one cell, if it's 3 volts, then it's only at 10% of its capacity. If it's at 3.4 volts, it's at 90%. So you can use your voltmeter on there, or quite often the BMS has its own little readout. It may have the voltage and or it may have the percent charge. For 4 cells, 12 volts, you just multiply these values by 4, and I've just done it in the spreadsheet here. Okay, so the future batteries. One of the problems we've seen is that certain countries have a virtual monopoly, or almost a monopoly, on lithium. So we're seeing some sodium-ion batteries coming out because there's a lot more sodium in the world. It's cheaper, it's more abundant, and it's got good or better cold weather performance than lithium, lower fire risk, but you pay for that with lower energy density. They're heavier, and they're still being rolled out commercially. They're better in a grid storage and backup power system than in a portable radio setup. There are more next generation lithium coming out, but they're not there yet. And a long-term candidate is a lithium sulfur battery. They're very lightweight, short cycle life today, and they're still quite experimental. So there's things that are still coming along. Doug was telling me about these aluminum air batteries that he was involved with a few years ago. They actually, the aluminum reacts with the oxygen in the air, and they have an extremely high energy density and fairly low cost because they use recycled aluminum. And they're very lightweight, but as you use them, the aluminum disappears. It's consumed in the process. So to recharge the battery, you add new aluminum plates. So it's quick to recharge. But you have to have a source of aluminum. And then there's some aluminum ion batteries, which are coming along. It's, again, next generation rechargeable, um, long lifespan, thousands of cycles, non-flammable, cheaper. But the problem there is most cells are less than 2 volts per cell. So you need a lot more of them to make up the voltage. And there's another one called aluminum graphene, which is being worked on heavily. So that's what I have. I will turn it back over and try to answer questions or have people make comments about things that they're um, interested in or they've discovered with their own battery packs they might want to share with other people. Not all at once.
Out of interest, Jerry, I looked at Amazon before I went on here to see about the batteries, and there's literally pages and pages and pages and pages of batteries. So, any idea who would be a good company to buy the battery from, or should we buy it from somebody in Calgary, like a reputable dealer?
Yeah, well, Jerry's a year late with his presentation, so I had to figure it all out on my own, so, because I was doing POTA and my AGM lead acid batteries, they did not last long, right? So I had to go and look around. So the GPS Central, what we call the candy store, they used to carry Dakota Life PO batteries brand, and they are not cheap, right? Like this is a good brand name, but what sold me on them, they had a return policy, right? You buy a battery, if in 30 days you decide that this is not what you want, for a 10% restocking fees, you can return it. So that's how I got my Dakota battery. And yeah, that's
Did you return yours?
well, not anymore because it's been over a year, but I could
No,
have
but you
done
were
it.
happy with it.
Yeah. Oh, yeah. I was very happy. I never ran flat on my POTA activations. I'm just trying to put all those numbers together. So it's not quite QRP. It's 25 watts I run on FT8. And I've done 5 parks on the charge, and I could have keep going, right? Like there was no issue with, getting out of battery.
Thank you, Rob. Who else wanted to say something? With Pat,
I posted in the chat a link to Adam Savage video that talked about the 18650 batteries, and there's a wide range of brands, and they x-rayed them and they tested them. So it's a 20-minute video, but I think that would be interesting to see what some of the not so high quality batteries, they purported to be competitors to the brand names, but they did not meet the performance specs and stuff. So I think it would be good info just to review that if you want to get into that level of detail.
yeah, I think it's quite difficult to choose when you're like Grant's saying. You go on Amazon and you'll see so many different types and whatever, and they may be very similarly priced. And then there'll be one that says Amazon choice, but again, you don't know if you know what that really means. They may make more money off of that one than other ones. I don't know, but or they may have a big stock of those. So it's always difficult, the brand thing. I'm familiar with now the ones that were in the presentation were recommended by ChatGPT. So whatever the whoever's paying Chat to advertise those, I don't know, but supposedly I asked them to put reputable company names on there. But again, that's a good question.
Okay, I have a question, Jerry. What I was hoping to learn is some sort of battery testers, right? Because I have a bunch of different batteries, right? Like I really like to know what they are capable of running, like a certain load, right? And I did get a Chinese AliExpress brand, and it was great. It was giving graphs on the computer, but it broke. So I wouldn't buy the same the same brand, obviously, but I thought maybe anybody can suggest how do you test the battery?
I'll ask Jerry QLT might have some thoughts on that.
Basic Ohm's law. And that, I mean, you've got the specs on the battery. So yeah, just build up a jig, and if you want to get really creative, yeah, build a little data logger and everything. But basically, what uh, the capacity of it is. You know what your charge rate is. And
Yeah,
that.
no, I had two identical 35 amp hour AGM batteries, and one ran for 40 minutes, another one for 5, right? So that's
Yeah, well, that tells you right there
yeah.
if they were both charged,
Oh no, they were
to
both
the
charged.
same.
It's just one
Yeah,
of them was worn out or whatever, right? Chemically
yeah,
bad, or I don't know
yeah,
how to describe it.
yeah. They just lose the capacity after a while. So, I mean, that's your test right there. Is if they're both charged up to the same amount of what the manufacturer says, then they should give you, a percentage of what the amp hour is, and that.
Yeah, gentlemen, it's Doug. Um, the rig blaster or rig runner, that rig outfit that sells rig blasters, they have a battery test system. It's where they have and you can connect it to a computer, and it'll show the voltage. You select the battery type, and it gives you a graph of the voltage versus load versus time. The only problem is to me it was too expensive. You know, uh, but anyway, it's out there. It's not a commercial uh, battery tester like the ones we got at work, but it'll meet the average ham guy's uh, uh, needs.
So here's another question I can add to the questions. A couple weeks ago, I was, it was more than that. I had some hesitation when my car was starting. It was quite cold out, so I thought, I wonder what my car battery is doing. And so when I took it for getting the tires changed, I asked them at the dealership. I said, well, I'm not sure about my battery, if it's healthy or not. He said, well, if it's working now, it's fine, but we can put it on a tester for you, and it'll be $80. I said, no,
You can get the same tester at Canadian Tire for 40, the same one they use, Jerry.
and test it anytime I want.
Yeah, exactly.
Yeah, those tests are a little different. They measure those cold crank amps or CCA, right? On the car batteries, that doesn't really apply to the our use.
Yeah, they're basically just a resistive load that you push a button and it starts heating up a resistor. And it's got a little meter on it to tell you, pass, fail, or midway in between. I got one in the garage, but another toy I never used.
Just one comment about some of the exotic battery systems, and that is the disposing of them. Most battery recycling places will not take lithium ion or lithium polymer batteries in that. We had about 30 pounds that was in an aircraft that crashed, and we tried to dispose of the batteries. They were swelling and everything. So we tried to even take them to the fire department, and they wanted nothing to do with them. So a lot of places will take NiCad and alkali, but you go in with any amount of the high capacity, high energy batteries, and they won't accept them. And that, So that's one problem that we're running into is just how to recycle or to dispose safely of the high energy batteries and that.
And that's because a lot of places have had fires.
Yeah, they're basically, when they're charged, and even down to 10% charge, they're basically a bomb ready to go off.
Well, and I was talking to Doug, the idea about that, because I have a lawnmower that's probably 15 years old, and I'm on the second nickel metal hydride battery. And I said, can I go to Battery World and have them build me a LiPo or LFP battery for it instead? They said that they will not touch that technology. They've had 3 fires there, and they will not build you anything with them, those batteries. So that's something that. So what did you end up doing, by the way, with those?
The tests we were doing was with the University of Calgary, and eventually we found out that the university does have a place to recycle lithium-ion batteries and that. Now, what they end up doing with them, we're not sure, but like I say, we were in a bit of a panic because we were transporting them from the airport back to the university, and we tried like 3 fire departments along the way and that, and nothing. And then finally, one of the professors got a hold of somebody at the university, and like I say, we were able to dispose of them there.
Wow. Yeah, it's a big problem with batteries and other hazardous materials. I still think that Malaysia airline MH370 was hauling they know that was hauling a huge cargo of lithium batteries before it disappeared, never to be found, although some debris has been found since. So
there's been a number of cases of people sitting at the window seat on airliners and their laptop sliding down between the side of the aircraft, and there's actually enough of a gap on some aircraft that it slides down into the cargo hold. And a number of airlines had to return back to get that laptop out. They were that just concerned about it, what would happen to it if it happened to get bumped or anything as it slid down into the cargo area.
well, I know they made a regulation years ago that they could not transport batteries, lithium batteries, on commercial airliners, except on certain lines didn't care, but most Western airlines prohibited it because of the safety. But anyway, hopefully, I haven't heard of too many incidents lately. I think they're doing something to improve the safety factor in there. I don't know what it is.
Yeah, there's still lots of cases of the e-bikes and that, especially the cheaper Chinese manufactured ones, of catching fire in people's garages and things like that. A lot of apartment buildings and condos will not let e-bikes be stored in the parkade or underground parking or anything like that. So one of the big things of building your own battery packs or coming up with that is make sure you build in some sort of safety system or a pre-warning system that it is starting to break down. And that.
It is now reaching DEFCON 5. Other comments, questions? Okay, well, thank you for putting up with that, and hopefully it was a little bit of information there. We'll post the presentation on the website as usual.